Hello friends, so in this particular video I will be walking you through function block diagram, how we can use it for the programming purpose in the PLC. So what exactly the function block diagram is? So when we define any function using block and the diagram in a graphical way, it is called as a function block diagram. So let me take you through how we can utilize this in the CoDeSys. So in order to add a program, we need to go to add object POUs, and then we'll get an option there to select program, function block or function. So we will give a name, and then we will select function block diagram in the implementation language. So it is one of the IEC 611313 language supported by all the PLCs. So when we created the program, we need to add the blocks. So as it says, function defined using block. So these are the blocks which we can drag and drop from the right hand side of the toolbox. We can put here the name of which the element which we want to use. So it goes in line with the digital systems, so where we go for logic gates. So here I have used AND gates, and I'm defining the variables and assigning the variables to these particular blocks. So uh, input is assigned. Let me assign an output. So in order to assign the output, uh, we can either drag and drop from there, or we can use the assignment element and put it there, drag and drop there, and then we can create a new variable or define a new variable using uh, giving the name. And so once we have defined all the variables, let's go and download it into the PLC. So I started the PLC. We will save it and then log in, or when we log in, then it asks for the download part. So let's download the code. So once we download, we will go into the run mode, but we see that this particular blocks are not getting executed. This is because it is still showing grayed out. So we need to call this in the main task, or the main PLC program which is getting called by the main task. So let me call it here, and we will define here the FBD and then put the small bracket and semicolon. So this is how it is called in the programs. And now we will download it again. And once we download, we will go to the FBD program, and we can see that we are able to see false all the places. So when we change, it will start changing the values, and as it is AND gate, so both input should be true in order to get the output true. So this is how it is working. Once we make it false, then yeah, output get false. So this is the very basic how exactly we can introduce. Now if you have to append the more inputs, so we can right click and append the inputs there. And if we have to remove unused variable, then just click on the remove unused variable. It will remove all the all the pins which are not used. So let me show you different blocks also how we can utilize. So all the blocks will be shown again in the toolbar on the right hand side. So we can drag and drop from there, and we can utilize that in the program. So when we put a variable there and click, then it will ask to get it defined. And we just have to select the scope and everything, and then the variable will get defined. So let me put var assignment for the output variable. Now when we are working with any maths block. I'm just trying to show means how exactly it work and what are the things we need to take care when we are defining these blocks. Okay, so you can see that as my initial value is 0 and we go into division, so it bring the PLC into exception, program loaded exception, correct? So these things we need to be careful when we are utilizing uh, the mathematical blocks or any blocks where we can think that it can bring it to exceptions. Exception handling is not taken care by us, then it can lead it to the program load exception, right? Because 0 by 0, and then that is a very basic point. Okay, so sometime when we get this exception, we have to again go with the online program download will not work, and then we have to either clean or go with download the whole program into and update the boot uh, project. So I'm just before starting, I'm just initializing with some value, and once these values are getting initialized, then okay, I'll put this into the run mode. So as it is in stop mode, so no values are changing. So once I change into run mode, the value will change. So the division functionality will start working. So let me again give 0. So whenever this 0 will come, of course it will be going into the program loaded exception. So these things we can check, and we can initialize those values so that we should not get any exceptions, and we can also handle this exception pretty differently. So again, I have to download the program and update the boot project to clear those exceptions which are loaded by the program. So now when we download, because these are getting initialized, so this will not lead to a or create any exception in the PLC. So this is another one. So when our numerator is 0, then it of course it will not go, because that doesn't cause any error or the exception, correct? How we can handle it a little differently also, let me show you. So let me get another block, which is okay. So these are the different blocks in every uh, different category. So other operator, function blocks, all the different function blocks, math operator, boolean operator, all are there. So let me drag and drop again. uh, uh, from the general, I can drag and drop a box, and let me give again the div. So there are two options to give it to utilize the block from the uh, right hand side from the toolbar. One is directly call that block, or call a box, and then inside that we can call which element or which function I want to use. So when we use a box with enable, then enable pin will be there, which we can utilize to enable and disable that particular block. So let me define all the variables. So once the variable are defined, let me download it. So if you see here, even I put a value as 0, it will not go in program exception handling. Oh, it went because of the rung 2. I have used the same variable. So let me change the variables at least. So let me create another variable. Okay, so this doesn't work because I didn't selected login with download. So we have to update the boot application whenever we get this program loaded exception. Now run, go in the run mode, and then we'll go. So if you see here, because this particular block is not getting enabled, so it is not getting executed. So once it is not getting executed, of course we will not see any error or any exception by the program. So this way we can also solve those exceptions. So we can create a logic something like not equal to, utilizing not equal to. So let's put not equal to there. So we can drag and drop on any pin where we want to connect any block. Okay, so when the denominator is not equal to 0, then only enable this particular block. So this is uh, another way of programming to solve the issue of exception given by the program for the division by 0. Okay, and now if you see, it is once the value are getting changed, the program is getting executed and there is no exception we are finding out. So let me show you another functionality, which is a jump statement. So how we can utilize that in the function block diagram. So we have to enable that var assignment first, and we have to give the label where the jump should happen. Okay, so let me put at a different place so that I can be able to show you how exactly it work. So let me insert the label on the rung 4. Okay, so I have given here the label, not one, label only. So here in the jump part also I should be giving the same name what I had given, and this particular segment I have to enable it. So if we give constant or true, then every time it will be true. So let me download it. Okay, so now if you see, the rung number 3 will not get executed because we are saying jump to label where the label is defined. So it is by passing the rung number 3 and going to rung number 4 directly. So rung number 3 is not getting executed, and rung number 4 will get executed. You will be seeing that the value of 3 is coming, but it is not moving to the variable. So whatever the variable we have assigned, it is not moving there. Okay, so when we make it false, you see it get moved to the variable also, because we have given a variable there. So it is working like that. You see, so when we enable it, the value doesn't get passed, and when we disable, then the value only getting passed. Okay, so let me take you to another concept where we will be using return. So this return element, what to do is, when the program is getting executed and it finds there's a return statement, return or return statement is mentioned and enabled, then it will return from there to the first one. So it will go out from the loop, and it will always go to the first rung and start from there. So it will not go to the next rung after the return. Okay, so let me define a variable to enable it. Okay, so right now I have given it here, but after that I don't have any rung to execute anyhow. So let me put it somewhere else. So we can even drag and drop the network, whole network itself. Okay. So let me download it. So once we download, as enable is true, so it is going to the label which is defined. Okay, so it is going by passing the rung number 3 and 4 and going to the rung number 5. So if I change any value here, this particular rung will get executed. Now when I enable the return, whether it is so, and change the value, it we can see that it is not getting actually executed, because enable is false for the jump statement. So it is from the rung number 4 it is getting returned. So once I change the value to false, then only the it will go to the next rung and it will get executed. Okay, so these are some different options which we can utilize. Now let me show you. We go to the first edit mode, and then the POU, it will not, it is not coming. So I had created few function and functional block, okay, which you can refer to the ladder logic programming, uh, where I will be providing the link in the description also, uh, where I had described how we can create a function block and the function. So I will try to utilize them in this particular video also, how we can call a different function or any function block in the function block diagram. So it is not showing here still because it is in the POU part. Okay, so in order to show it in the toolbox, uh, either we can bring that into the application directly, or what we can do is we can insert an empty box, or insert an empty box, and we can call. So we can, when we click, we can go to the function block and we can see what all the function blocks are there. So if you see, if I go to the ladder folder, I see there is one pump function block, so I can directly use it. So when I click there, and then after clicking, when we double click, it will come into the block. So any function block, so there were, one is the variable function block. I have utilized it here. Now when we can define the name, the same manner how we define a variable. So this is the instance for that particular variable underscore FB. Okay, so this is how we can call any different function block into the program of the function in the function block diagram. So other ways to drag and drop the box, and if we want to use any function, so we have to click on the PUU program and function block functions call, and then we can select the functions from there. Whatever the function are there in the project, all the function will show there, and we can basically uh, call it into the function block diagram. Let me define all the variables so that we can see the execution of this particular function. This is how we defined, and once we download, yeah, we can execute these blocks. Okay. So this is the very basic all about how we can call the different function block into the function block diagram. So the flow of this particular diagram is from top to bottom or left to right. So if we have multiple blocks, then it will move from left to right and then top to bottom. So let me show you how exactly the flow goes on. So let me insert another block uh, with in the same rung with the division. So I'm just adding multiplication there and provide a variable. Let me add another element, so add function, and then provide a variable for that. So this has become a kind of sequence from left to right. Okay, so let me save it and download it. So how exactly it works, it will move from left to right, it will execute the first rung from left to right, and then it will go to the next one. Okay, so this is how what when we are changing the value, we are getting the output. But now so now if I have to connect the output of those functions to another to the input of another block, okay, how we can do that? So let me drag and drop a new block here which is greater than, and if I'm trying to connect it the output of multiplication to the greater than input, the input 1 or input 2 or anywhere, it is not getting done. Okay, so how we can do? So for that, what we have to do is we can use the uh, either, so we have to use the assignment and drag that to the place where we have to assign a variable, and then we assign, it will give me a branch from there, and we can assign a new variable of the which will be the output of that particular multiplication block, or to anywhere from where we are taking that as a branch. So like from the division I'm taking one branch, from the multiplication I'm taking one branch. Okay, so let me change the variable for the add, so add out. So now for all the blocks I have one branch and one variable defined, so that particular variable I can use it in the next rung or wherever we want. So these are the local variables as it is coming under var. Okay, so we can provide them here directly, either drag and drop or put the name of the variable directly there, so it will get assigned. Now the output of the greater than, either we can have a assignment or we cannot have, so that's up to us. Okay, so let's download. So if you see right now the color of the output of greater than is black. Let me change the values. color got changed, correct? So color is now blue. So once it is in one is greater than in two, then the color will change for that. Now let me show you another block which uh, in which we can write some structured text code. So that is execute block, and we can call that inside the function block diagram, and we can write the structured text code here. So this is another option. So for example, when we have some complex algorithm or some complex equation which we need to solve, so structured text can be pretty handy to do all those things. So I'm just giving a example how we can utilize this execute block here. So let me put some code, and then we'll see how exactly it works. So now I have defined all the logic. So let me download the code and see how exactly the execute block work. So when it is get enabled, then it will, what it will do, it will just provide the it will run the logic which is written inside in the structured test. And let me change the value. So right now I put add one as 5. Okay, so okay, let us check whether the values are changing or not. So let me go to, let me put a breakpoint here, so it will help us to understand how exactly it is behaving. So let me go one by one step each. So gt out is false. So no, we can go to next step by clicking on, yeah, the step out, step in basically. So step into, and then one by one step will get. So it is trying to execute, and then yes, the value doesn't change. So let me change the value of live1, and okay, now you see it is started toggling, correct? So it is getting return first 5, then it is basically toggling between the output which is getting generated by the multiplication out minus addition out, addition 1. So what is the difference it is coming? It is trying to put the value there. So this is how exactly the execute blocks work. So let me enable the toggle, and then let me go online again, and then we can see one by one, going one by one step, how exactly it is behaving. Step into, so if you see the value got changed to 15, because that was the assignment done. So one interesting thing in CoDeSys is that once you have created a program in FBD or in ladder, you can convert it from one view to another view. So right now, for example, I'm seeing the ladder, and if I want to see that in function block, then we have to click on the function block view. So let me go to ladder FBD first. So right now it is an FBD. Click on the FBD ID view and view as a ladder logic. So if you see, the whole program will get changed to ladder form. And same thing if we go to ladder program and change the FBD view to ladder view to FBD, then the rung will changes to graphical form and it will show it in the FBD representation. Thanks for watching. That's all for this video. See you in the next one.